Hi guys, this video is about completing the square in order to solve quadratics. Just to give you a bit of context as to why that's useful, let's think about what we have been doing with factorization. So let's say we've got something like x squared minus 4x minus 5 equals 0. What we've done is we've done some factorization where we say, okay, what are the factors of negative 5 that add together to give us negative 4. Well, in this case, if we were factorising that, we would make that x take 5, x plus 1, because we know that negative 5 multiplied by negative 1 is negative 5, and negative 5 plus 1 is negative 4. So we're able to factorise that, and then we use what we call the null factor law to say, well, if these two brackets multiplied together equal 0, then one of those two brackets has to equal 0. That's the only way that's possible. So what we say then is that x equals 5 or negative 1. And as some of you have said, that's kind of like the opposite of the number here. If it's negative 5, this is positive 5. If it's plus 1, this is negative 1. So what happens when we get a quadratic that we can't solve by factorization? So for example, if I've got x squared plus 4x plus 1 equal to 0, well, the only two numbers that multiply together to give me positive 1 are positive 1, positive 1, or negative 1 and negative 1, and neither of those combinations give me 4. So what am I going to do? Well, this is where completing the square comes in, because it actually allows us to solve any quadratic. And it's very similar to how we completed the square to convert circle equations from expanded form into factorized form. So we're going to sort of follow the same sort of method. So first of all, what I'm going to do is I'm going to go x squared plus 4x equals, and I'm going to move the 1 to the other side. So that's going to become a negative 1 because I have to subtract 1 to get it to the other side. So the first step is to move the constant to the right hand side, and I've got all of the x values on the left hand side. Okay, what am I going to do next? Well, I'm going to do something very similar to what we did with the circle. The second thing I'm going to do is I'm going to add b over 2 squared to both sides. Now, if you remember, if we think about the general form of a quadratic, it looks like ax squared plus bx plus c equals 0. So b is the coefficient of x. So in this case, b is 4. So what I'm going to do is I'm going to add 4 over 2 squared to both sides of the quadratic. Now what this does is it actually forms a perfect square on the left hand side. And what that means, if it's a perfect square, is that we can factorize it as x plus whatever is in the brackets here. So in this case, it's 2 squared equals whatever it comes out on the right hand side. So this will be negative 1 plus 4 over 2 is 2. 2 squared is 4. So let me just write that out. Negative 1 plus 4. So now I've got x plus 2 all squared equals negative 1 plus 4, which is 3. I just want to clarify this. So the 2 here that I've got in my factorized form, this is b over 2. b was 4. Okay, now, have I solved the quadratic? Well, not yet, because I need to know what x is. What value of x solves this equation? So the next step that I'm going to do, and I'll write this on the side here, is take the square root, I'll just write SR, of both sides. So what I'm going to do is I'm going to take the square root of the left-hand side. Since that's all squared, the square root is just whatever's in the bracket, so that's x plus 2. And then I'm going to take the square root of 3, but I need to do something special here. Remember that when you take the square root of a positive number, the two possible answers are positive and negative. So we need to put a plus or minus out the front. Now at this point, just leave it as square root 3. Because we're looking for an exact answer, not a rounded off decimal answer. We want an exact answer, so we need to leave it as the square root of 3. Now the final thing I just need to do is take the 2 to the other side. So that's going to become negative 2 if it shifts to the other side. So my two possible answers are negative 2 plus root 3 and negative 2 minus root 3. Now as you can see, this is not a whole number. So there's no way that we could have factorised this. But by completing the square, we're able to get a solution to the equation anyway. Okay, I hope that helps. One other use of completing the square, by the way, is to rearrange quadratic equations to make them easier to plot, and we'll learn a bit more about that in class. Thanks very much for watching.